Hello students, today in this video we are going to revise series and parallel combination. This topic is from chapter electricity. The combination of the different resistors. Resistors are the component having some resistance. It is a common name given to the resistance. Okay, so these resistors can be combined in series combination as well as in the parallel combination that we have to study. Okay, now first of all we'll take series combination of these resistors. Series combination means two resistors represented by this symbol are connected in a single line. Okay, suppose this is the resistor 1, so it can be named as R1, and this is resistor 2, it can be named as R2, right? Now in the series combination concept, we want to find out the total resistance of this combination of resistors. Okay, the resistance of this resistor is R1, resistance of this resistor is R2. So the total resistance we have to find out. Total resistance in this case can be represented by RS, total resistance in series combination, or it can be named as equivalent resistance. It is also known as equivalent resistance. Another name of this total resistance is effective resistance. Effective resistance. So we should be able to find total resistance or equivalent resistance or effective resistance. Total resistance in series combination can be represented by RS. Equivalent resistance can be represented as REQ, and effective resistance can be represented as REFF. Okay, so these are the names given to the total resistance, okay, in any type of the combination, right? Now how to find out total resistance in the case of series combination of resistors? First of all, we can combine these two resistors in series combination and connect both of them with a battery and a key to complete the circuit. Okay, the current is flowing in this direction. This is the positive terminal of the battery, this is negative terminal of the battery, this is a closed key, right? Current direction I, total current is in this direction, and what is the potential applied to these two resistors? It is V, potential difference V is applied, right? Now to find out the total resistance, we must know the basic concept. What is the basic concept? In the series combination, when the resistors are connected in a single line, okay, then current remains same. Current flowing in one single line, that will be same through both R1 and R2. So through both the resistors R1 and R2, the current is same, I is same, that we need to remember. This is important concept. And the potential difference V, this potential difference will get divided, because potential difference is measured between any 2 points across the resistor. So across R1 resistor the potential difference is different, across R2 resistor the potential difference is different. So V is not same across R1 and R2. V, that is potential difference across R1 and R2, will be different every time in series combination, right? So these two things are very important to remember and important to understand, right? Now, based on the concept of Ohm's law, according to Ohm's law, we know that V is equals to I multiplied by R. Ohm's law says this, right? So in the series combination, because I is same and V is different, so total V will be equal to the V across this R1 and V across this R2. Okay, so we start from here and we can find out a mathematical formula for series combination. Total V is equals to V1. V1 is potential difference across R1 plus V2, that is potential difference across R2. Okay, now according to Ohm's law, we will use Ohm's law over here. V is equals to IR, so we can put the value V is equals to IR over here, right? I multiplied by R, that is equal to, for V1 we can write down according to Ohm's law as I R1 plus I R2. Okay, we are keeping I as I only because total current is same flowing through R1 and R2 because it is in the same line, right? So over here we can take this I as common. It becomes in bracket R1 plus R2. This I can be cancelled out on LHS and RHS. Then R, total R, that can be represented as RS or R effective or R equivalent, that is equals to R1 plus R2. This will be the formula for series combination. Okay, now next is how to find the total resistance in the case of parallel combination, right? Parallel combination means, as its name suggests, one resistor R1 combined in parallel to another resistor R2. These both are connected like this and they can be connected to the battery like this with a key maybe, and then the circuit is complete. The current direction, again I am taking it as this, and this is the potential difference, right? Now in this case, parallel combination, we can see the current I is flowing in this wire, and from here the two wires have been divided and the current flowing through this and this will be different. That means the current is divided over here in the parallel combination. So in both resistors R1 and R2, I will be different, and V, that is potential difference, will remain same. Potential difference is measured across the 2 points, so these 2 points are same for R1 and R2, across which potential difference can be measured, right? Now these two concepts are important for the case of parallel combination. Now how to find out the formula for parallel combination, right? So in this case, because I is different, we can consider I, total I is equals to I1 plus I2. I1 is the current flowing through R1 and I2 is the current flowing through R2, right? So according to Ohm's law, according to Ohm's law, V is equals to IR. So it implies that I is equals to V upon R, that we can use. So I1 is equals to what it will be, V upon R1 plus I2 is V upon R2. So why it is V only? Because V is same for both the cases R1 and R2. So for I it will be like V upon R. Total I is equal to total V divided by total R. Now what is total R over here? It is nothing but total resistance or effective resistance. We take V common over here, then what will be remaining in the bracket? It is 1 upon R1 by 1 upon R2, right? So V is cancelled out. It becomes 1 upon R is equal to 1 upon R1 plus 1 upon R2. It can be represented as RP, the total resistance in parallel combination, right? So it can be written as R effective, it can be written as R equivalent also. So this will be the formula for parallel combination, right? So one formula we have done for series and one formula we have done for parallel combination, right? I hope you understood this and you have revised this concept for series and parallel combination. Then in the next video we will understand how to do the numericals based on these formulas, right? Thank you.